Hello and welcome to a screencast on isolines. Isolines are lines that connect points of equal value. This could be for temperature, barometric pressure, or air pressure, or even elevation above sea level. You've probably seen isolines before, such as in this diagram here, when you have points of equal temperature, they're connected by a line. Here this would be barometric pressure. This is for winds. And this is a map that's connecting points of equal elevation. We call these contour lines. Points that connect equal values of temperature, we call those isotherms. If you have points of equal air pressure, we call those isobars. And again, repeating myself, contour lines connect points of equal elevation. Now there are some rules for isolines. Because they connect points of equal value, you can't have two isolines that intersect. They're always curved, usually smooth, they follow a regular pattern, okay, and they're either closed or they go to the edge of the map. As you can see here, these isolines go to the edge of the map on the United States, as do the isobars here. Contour lines, this is a zoomed in view of a particular area. So you can see at the edge of the map here, they would continue, but they go to the edge of the map. Looking at this map here of isotherms, we could either determine the temperature of a location or at least estimate the temperature of a location. If we have a location here, it's on the 80 isotherm. So then I can say that this location here would be about 80 degrees. A location located in between the two isotherms is between 80 and 75, so I can estimate that it might be around 70. I'm sorry, not 70, in between 75 and 80. So in between 75 and 80, you have 76, 77, 78, 79, and then this line would be 80. So it's somewhere in between 75 and 80. So if you said 76, 77, or 78, that would be a correct value for in between these two isotherms. And a location here, this would be 70 degrees. This is because it's located on the 70 degree isotherm. So, if I were to ask you what is the temperature of this location here in Texas, you would tell me that it is, right, 85 degrees, because it's on the 85 degree isotherm. Here's another map of isotherms. This map is representing January temperatures in degrees Fahrenheit for a particular location. Typically, you can see here that the isotherms are counting in a regular interval. The interval here is an interval of 10. It goes 65, 75, 85, 95. Now let's determine the temperatures for these particular locations listed. We have location A, B, C, and D. What do you think the temperature for the location A is? Location A, you should get 85 degrees because location A is located on the 85 degree isotherm. Location B, which is over here, is located on the 75 degree isotherm. So location B is 75 degrees. Now location C is not on an isotherm. Instead, it's in between two isotherms. It's in between my 85 degree isotherm and my 95 degree isotherm. Therefore, there's a range in values that it could be. Whichever isotherm that it's closest to, that would be the better answer, but the range in values is okay. I have for my location C about 90 degrees. Then location D, which is right here. That is also in between two isotherms. It's between my 75-degree isotherm and my 85-degree isotherm. Doesn't look like it's closer to any one of the isotherms. Remember, in between 75 and 85, we have 76, 77, 78, 79, 80, 81, 82, 83, 84, until you have 85. So for location D, I have about 80 degrees because it appears to be directly in between the 75 and 85 degree isotherm. Now let's take a look at contour lines. Contour lines connect elevation above sea level. Here you can see we have a little island, and the little island has this elevation above sea level with 3 small mountain peaks. And from a side view, our profile view, we can tell the elevation above sea level because we're looking at it from a side view. And here's our contour interval. Here's 0, which would be sea level. We have 500, 1,000, 1,500, 2,000. Okay, which means that every point at this 2,000 line, all these would be 2,000 feet above sea level. It says here that my contour interval is 500 feet. This makes sense because looking at this map, we're counting by 500s. Any location here would be at the 500 foot above sea level line. From an aerial view, we can't see the elevation above sea level. So on a map that indicates elevation above sea level, this is what it would look like. These are what my contour lines would look like. So this is the exact same map as the one here, except for this is an aerial view if you were standing directly above the island looking down. So here we have 0, sea level, 500 feet, 1,000 foot, 1,500, 2,000, 2,500, and then we have our 3,000 mark. Now, because contour lines are isolines that connect elevation above sea level, equal points of elevation above sea level, the value of a point right here, because it's on the 500-foot contour line, would be 500 feet. The point here is at an elevation of 1,000 feet. Now looking at a point in between these two contour lines, it's between the 500 foot and 1,000 foot, you can estimate that's between 500 and 1,000 feet. Now because this is counting by regular intervals, you have 500 foot intervals here. You have 2,500, 3,000, 3,500. The 4,000 contour line is not drawn here because 4,000 feet does not exist. If it did, then the 4,000 foot contour line would be drawn. However, because it does not, you can estimate that the range in values from 3,500 going up the mountain further would be between 3,501 and 3,999. However, 4,000 does not exist, or else the 4,000 foot contour line would be drawn. Here's a pretty simple contour map. This is connecting points of equal elevation above sea level. You can see here that it starts at 760, goes up to 840. So let's start with determining our contour interval. What do you think the contour interval of this map is? We've determined that the contour interval is 20 meters, which means it's counting by 20. We have 760, 780, 800, 820, 840. Now determine the elevation for location A. Location A is located on the 780 contour line. Therefore, we can determine that the elevation of point A would be 780 meters. Looking at location B, determine the elevation for location B. Location B is in between 800 and 820. So you have the values in between there. You have 801, 802, 3, 4, and so on until you get to 820. So the elevation of location B is about 810 meters. I picked that value because it's right in between 800 and 820. However, if I had a location that was closer maybe to my 800 contour line, I would probably pick a value that was closer to 800, like maybe 801, 802, 803, something like that. Let's take a look at another topographic map. Here we have a shield volcano. This is, I believe it says Mauna Loa volcano, one of the islands of Hawaii. Let's try to figure out the contour interval for this contour map. I can see my values here. We have 1,000, 2,000, 3,000, 4,000. Looking at those values, it looks like the contour interval here is 1,000 feet. Now, I determined that it was feet because down here I have feet. It tells me that the interval is counting in feet. Let's look at the value for point A. Now here we have our 1,000 contour line, and if we're counting by 1,000 feet, that's our contour interval. This would be a value of 0. We can also determine that this is 0 because it's sea level. Sometimes the maps will have the ocean labeled. So here we have Pacific Ocean, and I just put this in, labeled. So if it were labeled here, we can determine that the first contour line, if it meets with the ocean, is at sea level. So therefore it would be 0 because contour lines measure elevation above sea level. Now we're going to look at this map. This is the last contour map we're going to look at. Let's determine the contour interval here. Contour interval that we have looks like it's counting by 20s. So our contour interval is 20 meters. Location A, the value for location A here. Elevation for location A is 200 meters. Location B. It's about 250 meters, and this is because it's in between two contour lines. It's not on one. Now location G. A little bit harder because it doesn't have a label, but you can determine the value of location G by looking at the values and the contour interval of the map. This contour line, the last one labeled here, is 200. So if we're going from 220 to 200 and the contour interval is 20s, then location G would be 180 meters. That would follow the contour interval of the map. So 180, 200, 220, 240. And it would allow us to determine the value of a location even if the line is not labeled. Well, that's the end of our Isoline screencast, and I hope you liked it.